use a right triangle to write each expression as an algebraic expression. Assume that x is positive and that the given inverse trigonometric function is defined for the expression in x. Well, when I look at this, a lot of the instructions are just kind of telling me that everything is okay. X is positive. Well, if x is positive, then the square root of x squared plus 4 is positive, and I'm taking the inverse sign of a positive value, which means the angle I'm dealing with will be in the first quadrant. Assume that the given inverse trigonometric function is defined for the expression. Well, that's really just telling me that this value is between -1 and 1. Since I know it's positive, it's between 0 and 1 inclusive, and I can take the inverse sign of it. Those instructions are really just set up so that, hey, I can proceed with not reckless abandon, but I don't have to worry with like values that actually don't work, like things outside of the domain of inverse sine, or angles not being in the first quadrant. So here I have the angle I'm actually thinking about on the inside there. So now I know that sine of theta is x over the square root of x squared plus 4. Theta is a first quadrant angle. I can draw a right triangle to represent it, and I'm feeling very good about what to do, assuming I know what I meant when I said an algebraic expression. When we say an algebraic expression, we just mean something that involves variables, addition, subtraction, multiplication, division, raising the powers and taking roots, and not the trigonometric functions. So we're just going to get an expression in x. All right, sine of theta is x over the square root of x squared plus 4. That is the opposite over the hypotenuse. We're missing an adjacent side, and the Pythagorean theorem would tell me that x squared plus a squared is equal to that thing squared. Well, and that's telling me what a is going to be, right? Because if I just cancel off this, I get a squared is equal to 4, and a has to be 2. There was my missing side this whole time. And I'm just looking for secant of that angle, right? Secant of this thing that I'm now calling theta, so I get to be a little lazy and just say secant of theta. Well, I would secretly think about cosine, right? Cosine is the adjacent over the hypotenuse, so secant is the hypotenuse over the adjacent, and I get the square root of x squared plus 4 all over 2, and that's it.